Okay, welcome to this lesson video for our third and final part for creating the unit circle. We're looking at angles 60 degree, 120, 240, and 300. And again, we're finding the sine, cosine, and tangent of these degrees. Just as a quick recall, we want to remember our side lengths for three special right triangles. In particular, when we have a 45, 45, 90, and the hypotenuse measures 1, then the two side lengths are radical 2 over 2 for both sides. When we have a 30-degree angle and the hypotenuse measures 1, using our side ratios for special right triangles, the short side measures a half and the long side measures radical 3 over 2. And what if I kind of just rotate this little triangle and put the 60-degree angle down here with the hypotenuse still measuring 1? The short side is now down here, which is still 1/2, and then this long side, which is opposite the 60-degree, will measure radical 3 over 2. Okay, so we're going to use these side measures as well as knowing our degrees around our coordinate plane. So over here on the positive x side, we're going to treat that as 0 degree. This is kind of like where we start. And we're going to work counterclockwise. So I'm going to go 90 degrees. And then when I go another 90 degrees, I end up at 180. And then when I go another 90, I end up at 270. And then if I go full circle, that brings me back to 360 degrees. Okay, so we're asked to first find the sine, cosine, and tangent of 60 degrees. So here's what we're going to do. Remember that this is 0 degrees and this is 90 degrees. And so I'm thinking about 60 degrees. Obviously, I fall in this first quadrant. 60 is a little bit closer to 90, so I'm going to draw my hypotenuse a little bit closer to 90. So this is going to represent the 60 degrees that I'm supposed to be finding. Now we always I'm going to drop my altitude to the x-axis and make myself a little right triangle. Okay, so then if this ray here, the hypotenuse of my triangle, represents 60 degrees, then this corner angle, is the measure from the axis, which we're counting as 0, to 60 degrees. So that corner angle is a 60 degree. Okay, and so if I think about those side measures that I started the video with, we're talking about the unit circle, so the hypotenuse measures 1, and so then that means my side measures are 1/2 and radical 3 over 2. So I'm asked to find sine, cosine, and tangent of the 60 degree, and so since I made this little reference triangle, it's actually really easy. I use this 60 degree as my reference angle, and so I'm going to label my three sides opposite, adjacent, hypotenuse from this angle. Obviously, h is 1. The adjacent side, here's a little rule, is always on the axis when we're talking about these reference triangles. So the adjacent's on the axis, and then obviously this leaves this side to be the opposite. So then we just want to think about SOHCAHTOA, and then I'm just going to run through and find these values for sine, cosine, and tangent. So sine is O divided by H. So that's going to be radical 3 over 2 divided by a 1. Divided by 1 isn't going to do anything to my number, so it's just going to be radical 3 over 2. Cosine, A divided by H, 1/2 divided by 1, it's just going to make it 1/2. And then tangent, O divided by A, let's see what happens here. Radical 3 over 2 divided by 1/2. Well, fiddlesticks, this one's a little bit harder. on a quiz or a test or something, you'll be asked to write your answer in radical form. So we can't really just plug this in our calculator because it'll give me a decimal. So we got to remember, how do I divide fractions by hand? And if you don't remember, we keep, change, flip. We keep the first fraction. We change the division to multiplication. And then I flip the second fraction. Keep, change, flip. Okay? Now, you multiply across the top and across the bottom, but what I can do here, I notice that I have these 2's that will reduce or cancel out. So I'm just simply left with radical 3 over a 1. Well, I don't need that 1 in the denominator, so my answer is simply just radical 3. So that's going to be my tangent value, square root of 3. So the next question asks us for what's the coordinate point where the hypotenuse touches the circle. So they're asking for that yellow point there. So, just what would be the coordinate, the ordered pair for you to end up at that yellow point? Well, it's not that bad. Think about how much of an x value you went over, which was 1/2, and what a y value you went up to reach it, which was radical 3 over 2. Okay, so now, don't worry about this part, I just copied the directions. We're finding sine, cosine, and tangent of 120 degrees. So if you think about our way around the coordinate plane with our degrees, 120 degrees, hopefully you can see, falls in the second quadrant. So 120 is, again, closer to 90 degrees. So I'm just going to draw it closer up there. I'm going to drop my altitude to the x-axis. I always want to go to the x-axis. And this represents 120 degrees, this first ray, this hypotenuse that I drew. So I want to find this angle of my triangle, obviously, because it's inside my triangle. So I need to know what's the difference between 180 and 120. Well, that difference is 60 degrees. Okay, so the same triangle I was working with in the first quadrant is just reflected across that y-axis. So my hypotenuse is still 1. My adjacent side over here, this long leg, is still radical 3 over 2. But now my adjacent side here, it's still 1/2, but thinking about a normal coordinate plane, this side represents negative x's, so it's negative 1/2. Okay, so then I just need to label OAH. Again, one's the hypotenuse, adjacent side is on the axis, and then this is obviously my opposite. So then when I run through sine, cosine, and tangent, sine O over H, radical 3 over 2 divided by 1, just be radical 3 over 2. Cosine, A divided by H, is going to leave me with negative 1/2. And then tangent, it's the same as before, radical 3 over 2 divided by a negative 1/2. Let the computer catch up with me, it's slow. It's the same thing we did before. We'd keep and then we'd change to multiplication and flip. So it's going to be a radical 3. It's just I have a positive number divided by a negative. Only difference is it's going to be a negative radical 3. Okay? And this time, to reach the circle, the ordered pair for this point, where the hypotenuse touches the circle, I would go back for an x value, so negative 1/2, and then up radical 3 over 2 for a y value. Okay. So now our next angle degree, again, don't worry about that, 240. So if this was 180 and this was 270, again, we're in this third quadrant. And 240 is closer to 270, so it's going to be, it's a little wobbly, but there's my hypotenuse. And then I'm going to draw my altitude up, because remember I want to go to the x-axis. Always go to that x-axis, okay? So this ray that I drew, the hypotenuse represents 240 degrees. And so I need to know, I need to know this inside angle. So to figure out what's inside that triangle, I need to think about the difference between 240 and 180, because those are the two lines that create that angle. So 240 and 180, well, that's 60 degrees again. And so my hypotenuse is still positive 1. Okay, the hypotenuse will be 1 all the way around, no matter what quadrant we're in. We knew that this side was negative a half from the previous triangle. And now this time, radical 3 over 2 is going to be negative, because in a normal coordinate plane, that would represent the negative axis being down. So now just OAH, let's see, that would be my hypotenuse, adjacent on the axis, and then opposite. And so when I do sine, cosine, tangent, sine would be O divided by H. So that would just result in negative radical 3 over 2. Cosine, A divided by H, just a negative a half. And then tangent, okay, it's the same numbers being divided, O divided by A, but they're both negative. So we're going to go back to being a positive radical 3. So how did I get to that point where the hypotenuse hits the circle? I went back negative a half, and I went down, so negative radical 3 over 2. If you haven't noticed, the x value is the cosine value, and the y value is just the sine value. Okay, last one. So we're moving to the 300 degree. So remember that this is 270, and this is 360. So 300 is closer to 370. So something like that. I'm going to draw my altitude up to the x-axis. I want to go to the x-axis all the time. So this represents 300 degrees. So I need to find this inside angle of my triangle to get started. So the lines creating this angle are my 300 degree and my 360 degree. So the difference between those two is 60 degrees again. Go figure. And so my hypotenuse is 1. This long side, like the third quadrant, is negative, because it's negative y's. Negative radical 3 over 2. And the hypotenuse is a half. No, sorry, not hypotenuse. The adjacent side, goodness gracious, is going back to being positive, because we're on the positive x side now. So h is 1. Adjacent's on the axis, so then that leaves this guy to be the opposite. And so my sine would be negative radical 3 over 2, O divided by H. Cosine, A divided by H, would be positive a half. And then tangent, again, O divided by A, the same numbers being divided, so it's radical 3, but one's positive, one's negative, so the final answer needs to be negative radical 3. And so last question, getting to this point on the circle, how do I do it? I go over a half, which is the cosine value, and then I go down negative radical 3 over 2. So that's the sine. So we've made it all the way around our coordinate plane. So that finishes us up with our unit circle. If you've missed the first two videos talking about when our triangles are 30 degree or 45 degree, you can catch those videos. You can find them on YouTube. This would be my suggestion to catch up on next, looking at the unit circle and coterminal angles, so you can find that on YouTube as well. But that's it for this one, guys. I will see you next time. Keep learning and have fun.